All right. If you don't have your unit circle out, you need to have it out because we're going to be using it. And example 1, evaluate the 6 trig functions at each real number. First one we're going to start with is theta equals 2 pi over 3. So on your unit circle, you need to locate 2 pi over 3. And where's 2 pi over 3 found at? It's angle 120. It's right here. Here's 2 pi over 3. Right there's 2 pi over 3. Here's 120. And so what's the ordered pair that goes along with 2 pi over 3?
Negative 1/2. And radical 3.
So this is 120 degrees. And its ordered pair is negative 1/2 square root of 3 over 2.
Like this entire chapter is like this, right?
That's all we read.
This entire unit.
So. Now we have to evaluate all 6 trig functions. So we need to find out what the cosine of 2 pi over 3 is. What's the sine of 2 pi over 3? What's the tangent of 2 pi over 3?
Would you just plug in 120 instead of 2 pi over 3?
Well, we're fine. I want exact answers. If you use the calculator, you're not going to get it. But remember yesterday, what did I tell you the cosine was? And today too. The cosine is the x value. So what's the x value here? Negative 1/2. So cosine is negative 1/2. Sine is the y value. So the sine of 2 pi over 3 is what?
Square root of 3 over 2.
Square root of 3 over 2. Tangent is y over x. Y is what?
Square root of 3 over 2.
Over 2 divided by negative 1/2. Now we're going to simplify this. We multiply by the reciprocal. Secant of 2 pi over 3, which is the reciprocal of cosine of 2 pi over 3. 2 pi over 3 is what? Negative 1/2. And what's the secant then? Negative 2. Cosecant of 2 pi over 3 is the reciprocal of sine. Well, sine of 2 pi over 3 is what? Square root of 3 over 2. So what's the reciprocal of square root of 3 over 2? 2 over square root of 3. Then you need to rationalize it. Multiply top and bottom by square root of 3. So give you 2 square root of 3 over 3. Then cotangent is the reciprocal of tangent. Tangent was this, so what's the reciprocal of that? Reciprocal of it, negative square root of 3. And then we multiply top and bottom by square root of 3, so that we get that the cotangent is negative square root of 3. Questions there? We're using the unit circle. Because I will know if you use the unit or circle or not as to if you told me that the sine of 2 pi over 3, if you gave me a decimal here. Because that's what your calculator is going to give it to you. We want exact. Questions? Right, you done? B, theta of pi over 2. You guys try this one. Pi over 2 is which angle on the unit circle? It's the 90. What's that ordered pair at 90? 0, 1. So what's the sine of pi over 2? 1. What's the cosine? What's the tangent? 1 over 0, which is undefined. You can't divide by 0. What's cosecant? Cosecant is the reciprocal of sine. So what's reciprocal of 1? 1 over 1 and you flip it? 1. The reciprocal of cosine, which is, well, cosine is 0 over 1, so that's 1 over 0, which is undefined. And then what's the cotangent? The reciprocal of tangent. If tangent is 1 over 0, what's the reciprocal of 1 over 0? 0. What if I say I want theta to be a negative? What does that negative do for us? We start here and go this way. That's positive. So if it's a negative angle, which way do we go?
The other way.
The other way. So 4 pi over 3 is 240. So I need to rotate it negative 240 degrees. Right here's a negative 180. How many more do I need to go to get to 240?
60.
60 more, so I need to go right up here to 120. I rotate the opposite way. Here's 180 plus another 60 gives me the 2 pi over 3. So this is the same as 2 pi over 3, which is the ordered pair negative 1/2 square root 3 over 2. And didn't we just do that one? Didn't we just do this? Example A. Example A, we just did theta, so the answers correspond with example A. Okay. Questions there? I'm using the unit circle. Okay, let's look at what a periodic function is. A function f is periodic if there exists a positive real number such that f of t plus c equals f of t. For all t in the domain of f. Smallest number C, for which f is periodic, is called the period. What a periodic function is, it's a function that repeats itself. And all of our trig functions are going to be periodic functions because when we start at 0 and we graph them, we're actually going to have the graph is going to, and when we hit 2 pi, what happens at 2 pi? It repeats itself. It's going to repeat itself. So for sine and for sine and cosine, its period is what? Well, where does it repeat itself at? At 2 pi. So at 2 pi, it starts over again. Okay? So the periods for sine, cosine, cosecant, and secant are 2 pi. For tangent and cotangent, the period is actually pi. And we will get into that more when we get into graphing these. And we'll look at more of those. Okay? Anyone not done? Then let's look at even and odd functions. What do you remember about even and odd functions? A couple units ago. An even function has symmetry with respect to
X.
the y. And an odd function,
Origin.
symmetry with respect to the origin. So cosine and secant are even functions. Which means that the cosine of a negative theta is equal to just the cosine of theta. And a secant of negative theta is equal to secant of theta. Then the sine cosecant tangent and cotangent are odd functions. Which tells us the sine of a negative theta is equal to a negative sine of theta. Cosecant of negative theta is a negative cosecant of theta. Tangent of a negative theta is equal to a negative tangent of theta and cotangent. Negative theta equals negative cotangent. Example 2. Find the following. The cosine of 9 pi over 3. Pi over 3 is the same as what? 3 pi. 3 pi is not in a unit circle. We stop at 2 pi. How do I get to 3 pi? Go around again. I start here and I go all the way around here. That's 2 pi. I need to go another pi to get to 3. So that's the same as pi. So it's the same as the cosine of pi. And the cosine of pi is,
Wait, why is it the same as pi?
because when I rotate 3 pi, I land right here. They're what's called coterminal angles. Okay. And then what's the cosine of pi? Is it 0? You guys are going to agree with me? Cosine of pi is 0? Oh, don't you dare agree with me. It's the same as 180, and it's not 180. The cosine is the x value,
Negative
which
1.
is -1. Don't always agree with me. Oh, I make mistakes on purpose. Sometimes not on purpose, but I tell you they're on purpose.
Most times not on purpose.
What?
Most times not on purpose.
No, most times it's on purpose. What you guys talk about? Sine of -11 pi over 2. Well, 11 over 2 is what? 5.5? So this is a -5.5 pi. So I start on my unit circle and I have to rotate 5.5 pi's. And I have to go negative. So I start here, 1 pi, 2 pi's, 3 pi's, 4 pi's, 5 pi's, and then a half a pi, which takes me to where?
90.
To the 90. So this is the same as the sine of pi over 2. And the sine of pi over 2 is 1? You sure?
Zero.
Sine is y.
Sine is y, so it is 1.
What did you say?
Sorry. Stop trusting me, I told you. Sometimes you can. Questions there? C. If tangent of theta equals 2/3, find tangent of negative theta. Any ideas? Negative what? How'd you get that?
Because tan of negative theta equals negative tan of theta. Tan of negative, yeah, so there it is. So wouldn't that make it
We look at this and we say tan of negative theta equals a negative tan of theta. Well, what did they tell us? They told us that tan of theta was what? 2/3. So tangent of negative theta equals negative 2/3. And then the last example, example 3, use a calculator to evaluate. Sine of 5 pi over 7 and cosecant of a negative 2.
Is this our last one?
What do you have to make sure happens first? Your calculator has to be in what? Not degree mode, but radian mode. You need to make sure your calculator's in radian mode. How do I know that the cosecant is also going to be in radian mode, not degrees? It doesn't have a pi.
Because it's reciprocal of sine.
Not necessarily. That doesn't have anything to do with it. How do I know that this 2 is radian and not degrees? No. If I want it to be degrees, if it was degrees, we'd have to put a degree symbol there. Since there's no degree symbol, it's implied radians. Okay?
That's the answer.
Those are the answers. See if you can get them.